right triangles. So the hypotenuse-leg theorem. If a right triangle is one leg and hypotenuse is congruent to another triangle's one leg and hypotenuse, then the right triangles are congruent. So example 1. So the following are true. So we have the segment AC, which is congruent to the segment AB. Segment AD is congruent to segment AD. And then we have the segment AD is perpendicular to the segment BC. So now we're going to prove that ABD, the triangle, is congruent to the triangle ACD using the hypotenuse-leg theorem. So when we do this, right, we're going to have our statements and our reasons. And we always start with what's given to us. So this is what's given, so let's go ahead and just write that out. So we're talking about the segments, and this is just given. We know that this is congruent because it's given to us, we are told. Now, so this is also given. Oops, this is supposed to be number 1. 2, given. This is also under different property. If this wasn't given to us, we could also call it the reflexive property of congruence. Right, that the equal sign with the squiggly on top means congruence, right? Anytime you see that, that means it's congruent or congruency. So reflexive property of congruence. Congruency, whichever one. And then, so now we need one. So now let's go back. What have we shown, right? We have shown that this looks like the hypotenuse. They're congruent to each other. We know that one of these legs is congruent with each other, right? So one of the legs and one of the hypotenuse, right? So we've proven one leg and one hypotenuse is congruent to the other triangles, one leg and hypotenuse. So we did that. The only thing we don't actually know is this a right triangle, right? We're just assuming it's a right triangle, but maybe it's not. So the other missing piece of information is we need to know that the angle ADB and angle ADC are right angles. Sorry, that they're right angles. And how do we actually know that? So if we were to say that this is right, this is a right angle, so they're 90 degrees, how would we know that? Well, it's actually given to us in this information. So we know that AD is perpendicular to BC. So the definition of being perpendicular is that there's right angles that come from it. So we can just go the definition of being perpendicular. So we just leave it short like that. And so we know those are right angles. And so now we can go to our final statement. So our triangle ADB is congruent to triangle ADC. And then the reason that these triangles are congruent, then we can say through the HL theorem. So the hypotenuse-leg theorem is shortened to HL, right? So that just means hypotenuse-leg theorem.